Alright, Math 1, functions review. So, these first ones are just going over some of the features of functions. So remember, increasing and decreasing, domain, range, positive and negative are interval notation. So when I go increasing, well, I can see it's increasing from this point to this point. But what I do is I look at the x values. So the x value of that would be -4. The x value of this would be 0. So I go from -4 to 0, and I put it in brackets. That's where it's increasing. Then where is it decreasing? Well, it starts decreasing here, decreases clear down to here. So what are the x values? 5 and 0 again. So from 0 to 5, it's decreasing. Okay. Now positive and negative. Positive is above the x-axis. So my graph is positive clear to this point. So again, it's x value, so -4, to x value of 3 is where it's positive. It's negative, it starts at 3 and goes till 5 because it's the x values. So from 3 to 5. Now domain, remember, is all the possible x values. So I start at -4 and I keep going until I get to positive 5. That's my domain. Range is the y values, so I start, my lowest is -5, and I have y values up until 7. And so if I look at domain and range, it essentially draws a box around my whole thing. Now max, min, x and y-intercepts are all just points, so those are the easy ones. So maximum highest point is 0, 7. That is also where it crosses the y-axis, so it's my y-intercept as well. Then my x-intercept crosses the x-axis here at 3, 0. And then my minimum, my lowest point, is right here, and that would be 5, -5. And there we go with the graph. Now if we're doing a table, that x-intercept is where the y value is 0, so my x-intercept would be here at -4, 0. My y-intercept is where the x value is 0, so it would be 0, -4. In this case, they end up being pretty similar. The maximum is our highest point, so I look at all my values. My highest value, y value, is actually 2, not 0. So my maximum would be -5, 2. My minimum, that lowest point, would be -5. So -1, -5 would be my minimum. Okay? Alright, now, positive and negative, we look at just the y values. So it's positive right here, negative right here. So positive, -5 to -4. And negative would be from -3 to 4. Okay, that range is all those y values. Because it's a table, I'm going to do all the values. So I start with my lowest. So -5, -4, -3, -2, 0, and 2. Domain would be all the x values. So -5, -4, -3, -1, 0, 1, and 4. Now, increasing and decreasing, we're looking at those y values. When are they going up or down? So 2 to 0, it's going down. 2 to -2, down. To -5, down. Now to -5 to -4, that's going up, and up, and up. So from here to here, it's increasing, and here to here, decreasing. So -5 to -1 is decreasing, and -1 to 4 would be increasing. And that's what it should look like for our table. Alright, now, doing some rate of change on intervals. So, remember, it's the change in x over the change in y. X over y. So to find the x, I go 5 minus 1. 5 minus 1 would give me y over x. 5 minus 1 would give us 4, so my bottom number is 4. Then from 1, so my y value is 16 to 5, y value of 104, I go 104 minus 16, and that gives me what my top number is. So that would be 88. Then 88 divided by 4, if I can simplify it, I do, which I can, would be 22. So my rate of change is 22. So 4, same idea. 0 to 3, 3 minus 0 is 3, so we'd have 3 on the bottom. Then at 0, we're at 1,000. 3, we're at 1194.05. So this minus this would give us 194.05, which I can just leave it like that, or if I really wanted to, I could find its decimal, which, if I do it, would be about 64.683 repeated. Okay. So looking at these, which has a greater rate of change between questions 3 and 4? Well, this has a bigger number than that one, so it's definitely going to be question number 4. Now, if we're given a graph, same idea. These are our x values, so where x is 0, my graph is right here. Where x is 30, my graph is right there. Okay, so I'm going to go down from 75 to, we'll say that's about 3, 4. We'll say 3. So 75 minus 3 would be negative. We went down, negative 72. And then from 0 to 30, we go over 30. It would be negative 72 over 30. Which, if we reduce that, we can either reduce it to negative 12 fifths, or we could say negative 2.4, or even negative 2 and 2 fifths. Either one of those would work. Alright, now if we're given an equation, right, we take that for our x, 20 minus 10, will give us 10, so our bottom number would be 10. Then to find the change in y, we're going to have to plug each of those into x. So I'd go f of 10 equals negative 3.2 times 10 plus 5. So negative 3.2 times 10 would give us negative 32, plus 5 give us negative 27. Okay, then I do it for 20, so f of 20 would equal negative 3.2 times 20 plus 5. So negative 3.2 times 20 would get double at negative 64, and plus 5 would give us negative 59. So I'd go negative 59 minus negative 27, and I'd get negative 32, which negative 32 divided by 10 gives us negative 3.2, which, since it's a linear equation, that's my slope. So I could have done a shortcut, and realizing that, would have been able to do it that way. Now on 8 and 9, these are exponential, so a little bit more difficult to deal with. So 4 minus 2 would give me 2, so my bottom number is 2. So then I take these x values, and so I'd go f of 2 equals 5 times 2 squared, and then f of 4 equals 5 times 2 to the 4th. Well, 2 squared, 2 times 2 is 4. 4 times 5 give us 20. So I get f of 2 equals 20. Then 2 to the 4th, that's 2 times 2 times 2 times 2. That would be 4. That would be 4. 4 times 4 is 16. So 5 times 16. 5 times 16 is 80. So f of 4 would equal 80. So then I'd go 80 minus 20, which would give me 60. So 60 divided by 2, which would give me a rate of change of 30. So number 9, do the same thing. 3 minus 0 first to get my bottom number, so it would be 3. Then I go f of 0 equals 10 times 2 to the 0, and f of 3 equals 10 times 2 cubed. 2 to the 0 is 1, so 10 times 1 is 10. So I'd go minus 10 here. 2 cubed, that would be like 3 of them, would be 4, 8. 10 times 8 is 80. So 80 minus 10 would give us 70. So 70 divided by 3 give us about 23.3 repeated. So that would be our rate of change for those ones. Okay, number 10 and 11 deal with this graph down here. So it says, given the graph below of f of x below, what is f of 2? So an input value of 2, so I go to the x value of 2, go up to my graph, and what's my y value? My y value is 6, so f of 2 equals 6. 11 says, given this graph, what is x when f of x equals 10? So go to 10 here, go over to where my graph is, then go down, so my x would equal 3. So f of 3 would equal 10. For 12, same I did, just with this linear graph instead of exponential. So input of 6, go up to my graph. What's my y value? My y value is 8, so f of 6 equals 8. Now what about when f of x equals negative 4? What is x? So negative 4. So it's crossing right here. That's our y-intercept. So x would equal 0. Alright, so 14 and 15, now we're just going to evaluate some functions. So kind of like what we did up here, the only difference is we're just doing this one part. Now notice I've got two x's on each of these, but it doesn't matter. So an input of 2, so I go f of 2 equals, any place there's an x, I replace it with 2. So 2 squared minus 3 times 2 plus 7. 2 squared is 4. Negative 3 times 2 is negative 6 plus 7. 4 minus 6 is negative 2 plus 7 is positive 5. So f of 2, this function equals 5. 15. Now I've got a negative 2. So I go f of negative 2 equals negative 2 squared plus 10 times negative 2 minus 5. Now on a calculator, if you just go negative 2 squared, it'll treat that squared without the negative. The negative should go inside, so if you're going to do it on a calculator, write it like that. Or just go negative 2 times negative 2, and you get positive 4. 10 times negative 2 is a negative 20, minus 5. 4 minus 20 would be a negative 16, minus 5 would be a negative 21. So f of negative 2 of this function gives us negative 21. And there's our answers. Alright, something weird happened on number 16. That's odd. It should read like this. Let me pull up my copy of the function. Review. So it should say, okay, so it should say using the function f of x equals 9x plus 45. How much money will Leroy make if he works 30 hours? So basically we're just evaluating our function for 30. So I put 30 in there for x, so 9 times 30 is 270. And then 270 plus 45 would give us 315. So f of 30 equals 315. When he works 30 hours, he makes $315. Alright, 17. Glorfindel is riding his horse. Elrond writes the function d of t equals 102 minus 35t to represent the distance d in miles that Glorfindel is from Rivendell after t hours of looking for Frodo. So which correctly interprets this linear function? Glorfindel is 35 miles from Rivendell when he starts driving. He is riding away from Rivendell at a speed of 102 miles per hour. I think that should say start riding. All of those should. Okay, so Glorfindel is 102 miles from Rivendell when he starts riding. He was riding towards Rivendell at a speed of 102 miles per hour. Glorfindel is 102 miles from Rivendell when he starts riding. He's riding towards Rivendell at a speed of 35 miles per hour. Or Glorfindel is 35 miles from Rivendell when he starts riding. He is riding towards Rivendell at a speed of 35 miles per hour. So what do these numbers mean, essentially? Well, since this is an explicit function, the number with our variable is our growth, our slope. And this is the starting point. So he's going to start 102 miles away, which eliminate A and D. Then that was a long long bell. Then he's subtracting 35 miles per hour from that, so he would be riding toward Rivendell at 35 miles per hour, not 102, so the answer has to be C. Okay, 18. Thomas is trying to measure how fast his fingernails are growing. They started out at 1 inch, and then he saw that they tripled every day. Write an equation to model this growth. So tripling means timesing by 3, so this is going to be exponential. So I'd go f of x equals my start number, which was 1, tripling times 3, and because it's exponential, it's going to be 3 to the x. So it would look like that. Okay, 19. You and your friend are growing bacteria for a science experiment. You started with 10 and then noticed they double every day. Your friend started with 50 while it grows at 100 every day. After a week, who will have more bacteria? Okay, well, a few ways you can look at this. First, you should notice that yours is growing exponentially. So you'd start with 10, so we'll just say u of x equals 10, and it's doubling, which means times 2 to the x. Your friend, which we'll call f of x for friend of x, he started with 50, but it's growing only 100 every day, so we're adding 100, so it's linear. Okay, whenever you deal with exponential and linear, exponential is always going to grow faster in the end, but let's say after a week, so after 7 days, what would we get? So 10 times 2 to the 7th, 2 to the 7th is 128, so 10 times 128 would be 1,280 after 7 days. Your friend, 500 plus 100 times 7, 100 times 7 would be 700 plus 50 would be 750. So you can see that yes, yours would grow. You'll have more bacteria because yours is growing exponentially, which always grows quicker. Alright, 20. Reggie and Zach are both preparing for the local bicycle race. Function A and B show how much they will be riding. Who will have ridden more after 10 weeks? So B here is the graph. So if I go to input of 10, my output value looks like it's going to be about 160. Okay. Now, Reggie bicycled 15 miles last week and plans 20 miles each additional week. So we started with 15, and then we're going to add 20 10 times, right? Or in other words, 20 times 10. So 20 times 10 would give us 200, plus 15 would give us 215. So looks like Reggie is going to has gone further than Zach. Alright guys, so there's pretty much everything you need, so make sure that you studied up and you're ready to go for this benchmark.